let's say you were asked whether the operator L of x is linear or nonlinear, and we're working in R3. So here I've given you an example of one operator, and just for some background, if you don't know, an operator is just something that's gonna take a function and give you a different function. So here, L of x, well, this is a transpose, so I'm gonna show you guys what L of x really looks like. I'm just gonna write it as L. L is equal to 2x2 minus 5x3 and negative 7x1. So what does this mean? This means that if I were to give you a vector with x1, x2, and x3, so the vector x is equal to, say, 1, 2, 1. And I apply this operator L to it, what do we get? Well, L of x is going to equal 2 times, it's going to take x2, and here x2 is 2, and then minus 5 times, and actually I'm going to change 1 to, say, 3, just so that you guys can tell what numbers are coming from where. So minus 5x3, which is 3, and minus 7x1, which is 1. This is also equal to 4 minus 15 minus 7. Okay, so that's all an operator is, but how do we check if this operator is valid? Or if this operator is linear, not valid? This is a valid operator. There are two conditions, and then there's obviously checking first if the zero vector exists. So our two conditions are A, we know that L of f plus g needs to equal L of f plus L of g. And B, L of some constant k times f needs to equal k times L f. So first let's check if the zero vector exists. If I give you L of 0, 0, 0, you should get back 0, 0, 0. And this is what we get. And then if we're going to check the first condition, A. And let me move some things over so that you can see. Okay, so let's check A. I'm going to say that L and then of f plus g. So we need two different vectors. And I'm going to call one vector A. It's going to be A1, A2, A3. And I'm going to have another vector B, which is equal to B1, B2, B3. So these are two separate vectors, any vector in R3. And we're going to check if our first condition, A, is true. So L of these two added together is going to be A1 plus B1, A2 plus B2, and A3 plus B3. So you should see that I'm checking this first left-hand side. If you add these two vectors and then you apply L. And that needs to be equal to the L operator applied to F. So A, the L operator applied to A, and then the L operator applied to B. So let's do that. L times A1, A2, A3, plus L times B1, B2, B3. And then I'm going to, using, this definition right here, what is L, I'm going to show you guys what happens to all our A1s and B1s, or A's and B's. So this right here, right, I'm just going to work under, this is equal to, well, the first one, our first row is 2x2. So here, this is x2. So if I do 2, I get 2a2 plus 2b2. Okay. And then the next row is negative 5x3. Well, this right here is x3, so I'm going to do 5a3 plus 5b3. Sorry, it should be negative. Negative 5a3 minus 5b3. And then the last row is defined by negative 7x1. And this is x1, or a1 plus b1. So negative 7a1 minus 7b1. So is that equal to, if we were to just apply the operator to A, and then just apply the operator to B, and then add those two together separately? So L applied to A is going to give you, so 2x2, which is A2, so 2A2, and then minus 5x3, so minus 5a3, and negative 7x1, so minus 7a1, plus, and then 2b2 minus 5b3, and minus 7b1. If I were to add these two together, do we get the same thing? Well, 2a2 plus 2b2, okay, we get this first one, that's correct. Minus 5a3 minus 5b3, perfect, we get the second row is correct. And negative 7a1 minus 7b1, and we get this third row. So they're equal to each other, and that means this operator, we satisfy this first condition. So now let's check B. Here for B, you just need one vector, right? So let's use the vector A, and let's use some random constant k. So we're saying that L of k times A needs to be equal to L of, or k first, k times L of F, or L of A, sorry. So let's do this. This is L KA1, KA2, KA3. So what I did is I just applied k to our A vector. And if you multiply k and A, you would get KA1, KA2, KA3. Is that equal to k times LA? Because I haven't worked this out yet. So k times LA. So what is this? What is L applied to KA1, KA2, KA3? That will be, well, our first row is defined by 2x2. So 2 times k a2, and then minus 5x3, so minus 5k a3, and then negative 7x1, so negative 7 times k a1. Is that equal to, if we were to apply k and then L times A? Again, L, let's just work with 2x2, so that will be 2a2, and then minus 5 a3 minus 7 a1. And if I were to multiply this, I would get, well, let me just write this. 2k a2 minus 5k a3 negative 7k a1 is equal to, and I'm just going to apply k to everything, so k, I'm going to write this side, 2k a2 minus 5k a3 negative 7k a1. And you'll know that these two are equal, so we also satisfy the second condition. And therefore, this operator L is linear in R3.